Video 9.2 Database Services. In this video, we will cover the following topics: Amazon Aurora, Amazon DynamoDB, Amazon Elasticache, Amazon Redshift, Amazon DocumentDB, Amazon Neptune, Amazon Quantum Ledger Database or QLDB, Amazon Timestream. Hello and welcome to this video. We already know what databases are and also learned about database service Amazon RDS. Now let us explore some more database services provided by AWS. As we already know about relational databases, let me brief you about non-relational databases. Non-relational databases provide a simple tabular structure without a processing engine built into the database software. So, the key difference with non-relational databases is the lack of a schema and transaction engine. This makes non-relational databases a little lighter, simpler, and perhaps less dependent on native database code. So let's delve deeper into the concept of non-relational databases. You might hear the phrase NoSQL used to describe non-relational databases such as DynamoDB, and you wonder what that means. Well, NoSQL can be defined as meaning no SQL. However, it more commonly stands for not only SQL. A little confusing, so non-relational is usually an easier descriptor than NoSQL. Either way, what it means to us is that NoSQL data constructs have the benefit of not requiring a schema. Amazon Aurora. Amazon Aurora is a MySQL and PostgreSQL compatible relational database engine that combines the speed and availability of high-end commercial databases with the simplicity and cost efficiency of open-source databases. Amazon Aurora is up to 5 times faster than standard MySQL databases and 3 times faster than standard PostgreSQL databases. It provides the security, availability, and reliability of commercial databases at 1/10 the cost. Amazon Aurora is fully managed by Amazon Relational Database Service or RDS, which automates time-consuming administration tasks like hardware provisioning, database setup, patching, and backups. Amazon Aurora features a distributed, fault-tolerant, self-healing storage system that autoscales up to 64 TB per database instance. It delivers high performance and availability with up to 15 low-latency read replicas, point-in-time recovery, continuous backup to Amazon S3, and replication across 3 availability zones or AZs. Amazon DynamoDB. It is a non-relational database. Now, Amazon DynamoDB is a cloud-native database, and it's designed for managing high volumes of records and transactions without you needing to provision capacity upfront. DynamoDB is a fully managed service. Its simplicity, scalability, and speed has made it the go-to database for online services that deal with high volumes of internet-based transactions. DynamoDB supports both document and key store object types, big point. What that means is it can support multiple data types at the same time without you needing to define a new schema or field type. That makes it a good choice if you need a database that can keep growing to meet demand with many different types of objects stored in it. DynamoDB runs as a web service, which we provision from the AWS console or via API. AWS also provides a downloadable version of DynamoDB that you can run locally on your computer or server. The downloadable version lets you write and test applications locally without accessing the DynamoDB web service. DynamoDB supports encryption at rest, so it can meet many compliance and security requirements. So, to summarize, DynamoDB is speed and performance. If we need to scale something up really quickly, we are not quite sure what type of information we are going to be collecting, that we just need to have a flexible service, then DynamoDB is a fantastic fit. Amazon Elasticache. The next in the family of non-relational databases is Amazon Elasticache. Now, Amazon Elasticache is a managed data cache service built from the open source Redis and Memcache database engines as a managed service. Amazon Elasticache can improve your application performance by providing a frontline cache to respond to read requests made to an application or to a database. Let's just delve into the differences between a cache and a permanent data store so we are clear on the distinctions. The purpose of a cache is generally to act as a fast access copy of data that is being read a lot. So, lots of read requests. A cache will hold a copy of frequently requested information as a way to reduce load on other parts of a service or application. To reduce the load on our claims database would be to implement a cache between the database and the claims application. A cache is ideal for holding frequently requested data, so the web application does not need to read those components from our permanent data store. A cache will generally hold data for a finite period of time. If a record is changed, the cache will compare, flush, and store the latest version of a record. So while Elasticache is a reliable and durable service by nature, Elasticache is more about speed than persistence. As a cache, it is different by design from a permanent data store. Using Amazon Elasticache, we could easily provision and implement Elasticache to sit between our main database and our web application. Read requests that are made over and over will be stored temporarily within the Elasticache database. Elasticache will respond and send that frequently requested data to the web application front end, meaning our main database does not receive so many requests. So which cache engine would we choose? Elasticache supports two database engines, Memcache and Redis. What's the difference? Now both engines provide a great cache solution, easily provisioned using the Elasticache service. A simple way I use to remember the difference between them is Memcache for simplicity and speed, Redis for features. Choose Memcache if the following applies to your situation. You need the simplest model possible. You need to run large nodes with multiple cores or threads. You need the ability to scale in and out, adding and removing nodes as demanded by your system. Use Redis if we have complex data types such as strings, hashes, lists, or sets, or bitmaps, for example. If we need persistence in our data store, or if we need to encrypt our data, if we need to replicate our cache data, or if we need automatic failover if our primary node should fail, and if we want backup and restore capabilities, if we need support for multiple caches, or we need to sort or rake in memory data sets, it's all about the features, and the Redis delivers on those. Amazon Redshift. Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective to analyze all your data across your data warehouse and data lake. Redshift is primarily designed to manage structured data. As well as storing data, Amazon Redshift is also able to process and transform the data within the database. Redshift delivers 10 times faster performance than other data warehouses by using machine learning, massively parallel query execution, and columnar storage on high-performance disk. You can set up and deploy a new data warehouse in minutes and run queries across petabytes of data in your Redshift data warehouse and exabytes of data in your data lake built on Amazon S3. Amazon DocumentDB. Amazon DocumentDB with MongoDB compatibility is a fast, scalable, highly available, and fully managed document database service that supports MongoDB workloads. Amazon DocumentDB is designed from the ground up to give you the performance, scalability, and availability you need when operating mission-critical MongoDB workloads at scale. Amazon Neptune. Amazon Neptune is a graph database service that makes it easy to build and run applications that need to use a lot of queries and lookups to quickly visualize data. Now, graphing data can require a complex number of connection strings and related queries. So, as a managed service, Amazon Neptune reduces the need for hardware provisioning and software patching. Setting up all the configuration or the backups required generally do get impacted if you have a lot of these queries to run and manage. So Amazon Neptune is an AWS native graph database engine It's optimized for storing data relationships and querying a graph quickly and efficiently. Neptune suits use cases such as knowledge graphs, recommendation engines, and network security, to name a few examples. Now, Neptune supports the popular graph models like property graph and W3C's RDF functions, and the respective query languages such as Apache, Tinkerpop, Gremlin, and SparkQL, which allows you to easily build queries that efficiently never get very highly connected data sets. Amazon Quantum Ledger Database. Amazon QLDB is a fully managed ledger database that provides a transparent, immutable, and cryptographically verifiable transaction log owned by a central trusted authority. Amazon QLDB tracks each and every application data change and maintains a complete and verifiable history of changes over time. Ledgers are typically used to record a history of economic and financial activity in an organization. Many organizations build applications with ledger-like functionality because they want to maintain an accurate history of their application's data. Amazon QLDB is a new class of database that eliminates the need to engage in the complex development effort of building your own ledger-like applications. With QLDB, your data's change history is immutable. It cannot be altered or deleted, and using cryptography, you can easily verify that there have been no unintended modifications to your application's data. Amazon Timestream. This is a fast, scalable, fully managed time series database service for IoT and operational applications that makes it easy to store and analyze trillions of events per day at 1/10 the cost of relational databases. Driven by the rise of IoT devices, IT systems, and smart industrial machines, time series data that measures how things change over time, is one of the fastest growing data types. Time series data has specific characteristics such as typically arriving in time order form, data is append only, and queries are always over a time interval. While relational databases can store this data, they are inefficient at processing this data as they lack optimizations such as storing and retrieving data by time intervals. Timestream is a purpose-built time series database that efficiently stores and processes this data by time intervals. This summarizes the database services. This brings us to the end of this video. Summary. In this video, we have covered the following topics: Amazon Aurora, Amazon DynamoDB, Amazon Elasticache, Amazon Redshift, Amazon DocumentDB, Amazon Neptune, Amazon Quantum Ledger Database or QLDB, Amazon Timestream. In the next video, we will learn about data migration services.